5-8, Part 2, Applications of Polynomial Equations. Okay, in this warm-up, I want you to state the domain of function f in interval notation. So what do we know about functions with a variable in the denominator? We know that that denominator cannot equal 0. So in solving this type of equation, the left side, x squared plus 81, we can't factor that because it's a sum of perfect squares. If it were a difference of perfect squares, it would factor pretty easily to x plus 9 times x minus 9, but it's not. So all we can do here is subtract 81 from both sides. You get x squared equals negative 81. I apologize that the square root symbols were there already. Close that. So the reason the square root symbols are there is we have x squared. We want to get x, so we're going to square root both sides. When we square root both sides, if you try to do that in your calculator, square root of negative 81 or square root of any negative number, it's going to give you an error. And the reason for that is, think about it, there is no number that if you were to multiply it times itself would give you negative 81. Or in other words, no number times itself would ever give you a negative. So if you think of, okay, square root of 81, that's 9. Well, yeah, 9 times 9 is 81, and negative 9 times negative 9 is also positive 81. So we're going to talk about what happens when we take the square root of a negative, what that really looks like in a later section in this chapter. If x cannot be, in this case, a non-real number, then x can be all real numbers. And so the way you show that in interval notation is negative infinity to infinity. Now this is somewhat of a trick question for the limited knowledge we have right now, so I would probably not ask this on a quiz or a test. This was more just to kind of show you that what would I do if I had to square root a negative number, and I guess what I'm saying is stay tuned, we'll get there. Alright, so we're going to do some word problems today. This first example, I'll read it, and then we'll talk about how we're going to set up an equation that helps us to solve for a specific variable. So here it says, during intermission at sporting events, it has become common for team mascots to use a powerful slingshot to launch tightly rolled t-shirts into the stands. Maybe you've been a part of this. Maybe you've caught a t-shirt at some point. The height, h of t, in feet of an airborne t-shirt, t seconds after being launched, can be approximated by the function h of t equals negative 15t squared plus 75t plus 10. After peaking, a rolled up t-shirt is caught by a fan 70 feet above ground level. How long was the t-shirt in the air? So the first thing I'd like to do is maybe draw a picture. Let me see if I did that. I can't remember. No. Okay. So I'm going to draw a picture here of what's going on, and then we'll talk about how to set up the equation. All right. So think of it this way. We're in quadrant 1. We have our height h of t, and we have our time t in seconds. What's going on is they're launching a t-shirt. It's going up. Whatever goes up must come down, right? So I know they're not launching it from the floor. In fact, I know they're launching it from 10 feet because that would be the y-intercept of this graph. Now, what we want to figure out is, after peaking, a rolled up t-shirt is caught by a fan 70 feet. So it peaks right here. So I'm going to draw this axis of symmetry where it begins to come down. A fan catches it. We'll just say that's right here at 70 feet. How long, or where are we on the t-axis? After how many seconds of being in the air did the fan catch it? So with all that, we're going to start by replacing our height h of t with 70. So we get 70 equals negative 15t squared plus 75t plus 10. Remember, we talked about in the previous section, we want our polynomial equation to equal 0. So our next step, subtract 70 from both sides. We get 0 equals negative 15t squared plus 75t minus 60. Now we want to factor the right side in order to solve for t. The GCF on the right side, negative 15. The reason I'm going to factor out negative, I want that t squared value to be positive. That gives me negative 15 times the quantity of t squared minus 5t plus 4. So now I'm just factoring what's in parentheses. I need factors of 4 that add up to negative 5. If I think about that, the factors are negative 4 and negative 1. So this factors down to 0 equals negative 15 times the quantity of t minus 4 times the quantity of t minus 1. Remember, solving polynomial equations, once we get down to linear factors, we set those linear factors equal to 0 and solve for our variable. So t minus 4 equals 0 and t minus 1 equals 0. Add 4, we get t equals 4. Add 1, we get t equals 1. Now the question is, which one of those is our answer? There's only one answer, but we got two answers. Well, check it out. If we go back to our drawing here, there are two times that the height of the t-shirt is at 70 feet. Once on the way up and once on the way down. This part is really important after peaking, right? So we can assume that on the way up we were at 1 second, and on the way down we were at 4 seconds. So got to be careful, read the word problem really carefully to see which solution makes sense. So we want to write our answer as a short sentence. So the t-shirt was in the air for 4 seconds. All right, next one. We're going to use the same equation, which was h of t equals negative 15t squared plus 75t plus 10. And we're going to determine how long a t-shirt was airborne if it's caught on the way down by a fan 10 feet above ground level. So let's take a look. Same process as before. We're going to plug in 10 for h of t. And then we want the polynomial equation to equal 0, so we're going to subtract 10 from both sides. When we do that, we get rid of the constant on the right entirely. So we get 0 equals negative 15t squared plus 75t. We're going to factor out GCF. In this case, the GCF is negative 15t, so we'll factor that out. We're left with t minus 5 in parentheses. So again, 0 product property at this time. We're going to set both factors equal to 0. So negative 15t equals 0 and t minus 5 equals 0. We want to solve both of those. So if we were to divide both sides of the first one by negative 15, we get t equals 0. If we were to add 5 to the second equation there, we get t equals 5. So again, which answer makes the most sense? Well, this is being caught on the way down, so it's probably not going to be 0 seconds. It's going to be 5. So the answer, the t-shirt was airborne for 5 seconds. Oh, there's the answer. Forget that's there, and let's go about doing this word problem. If each side of a square is lengthened by 6 centimeters, the area becomes 144 square centimeters. Find the length of a side of the original square. All right, so the first thing I want to do is draw a picture. So in the original square, that's what we don't know. So squares, remember, are 4 right angles, 4 congruent sides. So we're going to call those lengths x, right? So just x all around there. Then the word problem says we're going to add 6 centimeters to each side. So that's, you know, this length here and this length here is 6 centimeters. So we're making a bigger square, and it has an area of 144 centimeters squared. So the length of this whole side from here to here we know is x, the original, plus 6. And that's going to be the same because square has 4 congruent sides. So that's x plus 6 as well. We know the formula for area is length times width equals area, or area equals base times height. So our length times our width equals the area. X plus 6 times x plus 6 equals 144. On the left side of that equation, I'm going to FOIL. When I FOIL that out, I get x squared plus 12x plus 36 equals 144. Remember, our polynomial equation has to equal 0, so we're going to subtract 144 from both sides. We get x squared plus 12x minus 108 equals 0. So my job now is to factor the left side. This is not too bad because a equals 1, so I just need to find factors of negative 108 that add up to 12. So those factors are 18 and negative 6. If I use the zero product property at this point and set both factors equal to 0, I get x equals negative 18 and x equals 6. So which answer makes the most sense? Negative 18 or 6 for the length of the side of the original square? Well, length can't be negative, so we know that the answer is 6 centimeters. Now, there's a much easier way to do this, but I'm going to ask that you do this type of problem this way using a quadratic equation. I'll show you the other way you could have done this, really quick and easy. The big square is 144, which happens to be a perfect square. So if I square root 144, this gives me the length of this x plus 6 side, so we know that this is 12 and this is 12. And then if we're told that we're adding 6 to the original, we could take away 6 to find the original. Now that was much easier than what I did with quadratic equations, but the whole purpose of this unit is to apply what we know about solving equations and into real world problems. So I'm going to ask that you do it the harder way just for this unit. I wouldn't ask that very often, but just this one time. All right, framing a picture. A picture frame measures 12 centimeters by 20 centimeters. So I drew a picture of that. And 84 square centimeters of the picture shows. So this area here is 84 square centimeters if you did your length times your width. So the outside length and width 12 by 20. The frame has a width of its own, and then the area of the picture is 84 square centimeters. So we want to find the length and width of that area. Well, we can take the long piece, 20, and then we're subtracting this width, x and x. We have to subtract it twice because it happens on both sides. And then same here. We know this long side here is 12, and then we have to subtract x and subtract x. So we know that's 12 minus x minus x. So length times width equals area. So 20 minus 2x, I just combined like terms there, times 12 minus 2x equals 84. Then I'm going to FOIL, first, outer, inner, last. I get 240 minus 40x minus 24x plus 4x squared equals 84. Combine like terms and write in standard form. I get 4x squared minus 64x plus 240 equals 84. Subtract 84 from both sides. 4x squared minus 64x plus 156 equals 0. Then begin to factor. I can factor a 4 out, and I'm left with x squared minus 16x plus 39 in parentheses, and then I need to go about factoring that trinomial. So I need factors of 39 that add up to negative 16. Those factors are negative 13 and negative 3. So I set those equal to 0 and solve. I get x equals 13 or x equals 3. The answer that makes the most sense is x equals 3, because the width of the picture itself, or I'm sorry, the height of the picture is 12 centimeters. It doesn't really make sense that the frame would be 13 centimeters wide on each side of the picture. So the width of the frame is 3 centimeters. Your homework for 5.8 Part B is on mathexcelforschool.com, due Sunday at midnight.